Hey everybody, today we're going to be talking about relative frequency. Now that's not your family tree and it's not all your relatives like your cousins, aunts, and uncles. It's what actually happens in an experiment. So grab yourself pencil and notes, and you want to get started with the calculator as well. You may want your math book to follow along, page 529 if you are with Holt still. And also the formative assessment that we're doing for relative frequency. Have that handy. You're going to be thankful you did. All right, let's get started. So relative frequency, what is this? So take notes on the back of your formative assessment. What actually happens in an experiment or an event? And it's expressed as a fraction, decimal, and percent because it is a probability. So you still write it, probability of whatever event you're looking for is equal to your outcome, and your outcome can be written again as a fraction, a decimal, or a percent. Today we're going to do all three fraction, decimals, and percents just to practice. So let's do this. So spinner was spun 500 times. So how many times in all? You got it, 500. It was found that the A occurred 170 times, the B 244, and the C 86. This person had too much time on their hands. I really hope they had somebody else doing tallies for them. I wonder how long that would take. Anyway, if we wanted to figure out the probability of landing on an A based on this experiment, we call that estimating for A. And the reason it's estimating is because we don't know theoretically what's going to happen, and this isn't theoretical, what should happen, it's what did happen. So since this was an experiment, we're finding the relative frequency, which is also known as experimental probability, of how many times A was actually spun. So I take the probability of A, I write that P of A equals. Then I have to figure out the number of times A was spun. So my probability of an A in this experiment, the relative frequency is A. Well, let's check. A 170 times. So I put 170 in my numerator. Now the total number of outcomes, be careful here, you're not going to add 500 plus 170 plus 244 to get 86 to get 914. It was spun 500 times. That information is already given to you. So all you have to do is write it like that. Now, what's wrong with this, you ask? Well, it's not reduced. If you reduce 170 over 50, you get 17/50. Now, that is one method, which is also equivalent to 34 hundredths, written as a decimal, which is also equal to what? To convert a decimal to a percent again, just move it 2 spots to the right because percent means out of 100. So we move it 2 place values when you multiply by 100, and you get 34%. So your chance or your probability of A in this experiment was 17/50, 34 hundredths, or 34%. Again, this is called the relative frequencies because what actually did happen in an experiment. All right. Let's find another one. Oh, by the way, that was number 1 on your formative. A coin was randomly drawn from a bag and then replaced. I love this problem. I'm such a geek, I know. But after 300 draws, it was found that 45 pennies, 75 nickels, 92 dimes, and 87 quarters had been drawn. What would be the relative frequency or the experimental probability of drawing a quarter? So, same setup. We have to figure out the probability of the quarter. So I take the number of quarters out of the total number of outcomes. So my probability of a quarter, I'm going to abbreviate quarter, I hope you don't mind, with a capital Q. You could write it out, probably be more accurate. The number of quarters in this bag that were drawn were 87. Now we don't know if there's actually 87 in there because based on the experiment we drew a quarter 87 times. This is a relative frequency, 87 times out of 300. So 87 out of 300. That can be reduced by dividing it by 3 over 3 to get 29 hundredths. Now 29 is prime and it doesn't go into 100. So you're done with 29 hundredths, but we want to write that as a decimal, 29 hundredths, and as a percent. Move it 2 spots to the right, it's equal to 29%. So 29% of the time, we drew a quarter. Awesome. Let's do this again, friends. Modes of transportation. All of you get to school a different way. Let's say I did a survey on the number of students, and I surveyed this many people. Well, how many people did I survey? Pause video, use your calculator, or your smart head, and figure out the total number of students that I surveyed. Yeah, I was busy, wasn't I? How many did I survey? I surveyed a total of 770 students. My total is 770 students. Wow, that's a lot. I want to compare my probability of walkers to my probability of bikers to see which one's greater. So to figure out the probability of walkers, I'm going to abbreviate P of walk. I need to take how many walked according to my survey, 105, of the students I surveyed. So out of how many kids did I survey? I had to add 265 plus 313 plus 105 plus 87 to get a grand total of 770. So 770 is my denominator. 105 out of 770 is reduced to 3/22. I want to write that as a fraction, but I also want to write it as a decimal. And the decimal's not fun. It's 0.136, and the 3/6 repeats, so I put the bar over the 3 and the 6. The 1 does not repeat, so I do not put the bar over that number. Now, this is tricky and a great review for you. So when you move the decimal 2 spots over to get it a percent, it's going to be 13.6. And you think, the 3 and the 6 repeats. What number's next? A 3, and then it's going to be a 6, and then it's going to be a 3, and then it's going to be 6. So the bar notation goes over just the 2 numbers that repeat. In this case, it has to be after the decimal. Bar notation only goes over decimal numbers. So 13.63 forever, and then a percent sign. That's my probability of walking. Versus, I love that channel, the versus channel, my probability of biking. So probability of riding a bike to school, hopefully it's warmer out, is 87 out of, again, I have to figure out how many kids I actually surveyed. So my denominator is 770. Now, 87 and 770 don't have any common factors, so this is already reduced for you. And if you have your ABC button on a scientific calculator, like a handheld, you'll be able to check. Otherwise, 87 is not go into 770. They don't have anything common, so you are done. You are reduced. But you need to change that to a decimal. So 87 divided by 770. And your decimal number, again, is ish. It is an irrational number. 0, decimal point, 1, 1, 2, 9 or 8, 70, 1, 3, and then your calculator just stops. But this number does not. Crazy number like this is called an irrational number. An irrational number means you don't know what happens next. So if, in this case, you get an irrational number, once you change it to a percent, it'd be 11.2987013 percent. We're going to round that just to make it easier. So the probability, probability of biking, P of bike, is approximately, that's that squiggly equal sign, it's called the approximate symbol, is approximately 11.3. I'm just going to round to the nearest tenth. And as long as you round correctly, you're all good. Percent. Now which one I have to compare? So which one of these is greater? 13%? 11%. Well, the probability of walking is greater than, so my alligator eats my bigger number. Probability of walking is greater than my probability of biking. Yay! All right, we're going to use the same information. So we already have the total of 770. We figured that out already. Okay? Like the locker bay? Yeah, friends. Where's your locker? Is it right here? Happy birthday to you. Okay. Anyway, we want to compare modes of transportation. So we're going to do bus to car. Probability of riding the bus, my friends, is probably a lot of you. So a lot of you ride the bus. 265 of you to be exact, out of the 770 kids I surveyed. So 265 out of 770 is equivalent to 53 out of 154 as a reduced fraction. Now, we could do a reduced fraction, but we can also do a decimal in percent. So I'm going to write it down here, 53 over 154. I'm going to get rid of this guy here. Just reduced it. And 53 divided by 154 is equivalent to 0.34415, and it keeps going as another irrational number. So when you're irrational, you have to write at least 4 decimal places and then put your dots to show that it's crazy. And then you round it to the nearest tenth of a percent, or however you want, 34.4%. If I round, I have to put that approximate sign. It is an estimate. Now it's the probability of riding the bus. Probability of riding in the car, P of car, is 313, which we got right here, out of my total of 770. So 313 divided by 770 is equal to the decimal 0.406493, and again irrational. So I move that decimal 2 spots to the right, and I get approximately 40.6%. So if I wanted to compare which one's greater, probability of car is greater than the probability of the bus because it has a bigger number. I think percents are a lot easier to compare than fractions, but if you're looking at fractions and they have a common denominator, you can do that. As long as the denominator is the same, you can just look at the numerator and it tells you which one's bigger. You can also compare decimals. You go to the first number that's different, and then which one's bigger, unless you're dealing with negatives, is the larger number. Now, technically, whenever you're doing relative frequency, your answers are always going to be an approximate symbol because it is based on an experiment. It's not theoretical, it's not what should happen, it's what did happen. So experiments can change all the time, so make sure when you're writing your equivalency symbol, whatever your event is, if it's based on an experiment, you should do the approximate symbol. And then your answer can be a fraction, a decimal, or a percent. They're all equal to each other. But again, since this is an approximation, it's relative frequency. Relative frequency is an experiment. You want to make sure you have that approximate symbol. All right, now I'd like you to get connected. I want you to show what you know after you complete your formative. You've already done 4 of the problems. Carry on and then get connected and see what's on the week at a glance to see where you are going next. If you have a question, please make sure you ask me what you're supposed to do. Love hugs. Thanks for being here and keep it real. Bye.